Hello and welcome to this week's episode of Math Matters. Why do I need to know this? I've got some neat stuff to show you today, some stuff that's kind of important especially for living in the state of Kentucky. And then some other things that involve investment strategies and just general kind of getting by strategies. I want to get started on a little piece here on probability. And mostly I'm going to be talking about counting. I know you think 1, 2, 3, 4, 5, that's counting. Well, that's kind of what I'm talking about. Really what I'm saying is counting how many ways certain things can happen and then how that affects. We'll end up talking probability before we're done. We are in a lottery state, and for that reason I think it's important for folks to understand some of the percentages, the chances of winning these things. And I'm going to take you through a little bit of that math this morning for how you calculate the odds of winning and those kind of things. Now, here in Kentucky, our big lottery in the state of Kentucky is Lotto South, and for $1 you get to pick 6 numbers 1 through 49 with no repeats. You get them in any order, you win. Now what we're going to do is learn how to count the number of possible tickets, and that's all we have to do. You can sell a Brazilian of these things, but if 2 people get the same winning ticket, they have to share the pot. So really what matters is what are the odds, what are the chances of picking that winning ticket. And so that's what I'm going to take you through now. And it all kind of starts with this idea called the fundamental counting principle, which just says this: the number of ways to place items into categories is the product of the number of choices per category. And product means we're going to multiply. So let me give you a little example. Let's say Bill had 5 different shirts, he had 6 different pair of jeans and 10 different pair of socks. And they're all compatible. They all, match some way or another. How many different outfits are possible? Well, all we do is we've got 3 categories: shirts, jeans, socks, and we put in the number of choices for each, 5, 6, and 10, and you multiply. And so he's got 300 potential outfits. Okay? Now, I can make things slightly different if I say, well, the choices are all kind of being removed from the same pot. And that gives me a chance to use some nice notation. Let me introduce this notation. This is called n factorial. It looks like n, because it's got that big N with the exclamation mark. But it just means you take n, you multiply by 1 less and 1 less and 1 less till you get down to 1. And we define 0 factorial to be 1. That's a notational thing. Hopefully I'll get to show you why we do that in just a moment. So if I look at a situation and say I had 5 runners and I ask, well, how many different ways can they finish the race? Well, I've got 5 categories and 5 choices for the first one. Then the choices go down, 4, and then 3, then 2, then 1. And see, that's 5 factorial, which equals 120. So there'd be 120 ways that could happen. In general, that means that there are n factorial ways to arrange n things. Okay, now let me change the situation slightly. Let's look at a situation where I've got 20 contestants and I want to say how many ways can they finish first, second, and third. Well, it's not 3 factorial, it's not 20 factorial. I've got 3 categories. I've got 20 choices for the first one, 19 for the second, 18 for the third, and that equals 6,840. But I can use that factorial notation. If you notice, I can write those and then have a 17 factorial in the top and the bottom, that's just 1. And then I can rewrite this as 20 factorial over 20 minus 3 is the 17 factorial. And that gives me a general way to arrange R of n things where R is no bigger than n. It's kind of this fraction right here. Now, I'm going to keep juking this. Everything I've done up to this point has had order involved. Now I want to take the order that things fall out of it. So let me give you another situation. Let's say there's 30 people at a reception and they decide they're going to shake hands with every other person in the room. So how many handshakes is that? Well, if we had a first handshaker and a second handshaker, it'd be 30 times 29. That's the fundamental counting principle. But there isn't really any difference between Bill shaking hands with Sue and Sue shaking hands with Bill. And we have counted those occurrences then twice. So what we do is we look at the number of different arrangements of the two things, okay, which is 2 factorial, and then we divide by that. And so that gives us, go back and flash the total here, that gives us the correct answer of 435 handshakes. And so that gives us then a general kind of formula then for how to arrange R, or not to arrange, but how to group R of n things where R is no bigger than n. This is our general formula that we had, and then R is what we divide by, because there are R factorial ways to arrange n things. So you kind of divide out the order, in other words. Okay, now I'm ready to address the Lotto problem. How many different lottery tickets are possible? We've got 49 numbers to choose from. We're going to choose 6, and it doesn't matter what order they fall. Okay, I'm going to use this formula. I've got 49 numbers to choose from. I've got, and then to get them arranged, I would say 49 minus 6, that's the factorial. And then to get rid of the order, I divide by 6 factorial. Okay? And then you just have to do the arithmetic on that, which sounds horrible, but it's really not. You can expand 49 factorial into 49, 48, 47, 46, 45, 44, and then stop at 43 factorial and cancel those big buggers out. Those are large numbers, but we can get rid of them pretty quick. The rest of this is just a division problem, which you can do on your calculator. Turns out that that is 13,983,816. That's how many different lottery tickets are possible. Okay? That's a big number, big number. Now, I want to look at probabilities for a second and chance. I want to talk about chance in general, because that's really what we're working for, is what's the chances? What are the chances that I would win the lottery? Okay? Well, we can talk about this in two ways. We can talk about probability, which is the number of successful outcomes, over the number of possible outcomes. Or we can talk about odds. We can talk, which is the ratio of successful outcomes to unsuccessful outcomes. Okay? Now they're very close to each other. And typically you see odds expressed like this with a colon between them. If you know one, you can calculate the other, but I'm not going to get into that. I mean, that's something we could do at a later date if you want to. I'm going to stick to odds because we're playing a game, and typically gaming things are reported in odds. So if we look at the number of possible tickets here, one of those is a winning number. The others will not be the great big winning number. So the odds of winning Lotto South would be 1, 2, 13, 983, 8, 1, 5, one less than this. Actually, on the Kentucky Lottery page, it says, it compares this to 816. What they did is they calculated the probability and then reported it as an odds, which is technically incorrect, but I'll give them a pass on that. And just out of curiosity, I went to the National Weather Service and I looked up the odds of getting struck by lightning. This is something you need to know if you're going to play the game in Kentucky. The odds of getting struck by lightning this year would be 1 in 700,000. That number is half the number we just calculated, which means you're twice as likely to walk outside and get struck by lightning this year as you would be to win the Lotto South in one play. That's stuff I think you need to know if you're going to be playing the lottery in the state of Kentucky. I covered a lot of stuff, so I'm going to flash up the important stuff on some summary pages here and let you kind of digest that for a few moments.